Now the next problem that we are going to study is an axisymmetric problem. Now if you remember, we have already discussed about what is axisymmetric. Whenever we have a model which is symmetric about an axis and the loads acting on the model are also symmetric about an axis, we will consider that object to be axisymmetric. Okay, so we will consider this problem now to understand how to solve an axisymmetric problem in Ansys Workbench. So the problem description is such that a long cylindrical pressure vessel of mean diameter d and wall thickness T has closed ends. It means the pressure vessel is closed at both the ends and it is subjected to an internal pressure P. Okay. Determine the axial stress, axial stress and the Hooke's stress in the vessel at the mid thickness of the wall. Okay. So this is what the problem states. So we need to find out what is the axial stress and what is the Hooke's stress. Okay. The material that is going to be used for this type of analysis, it is a material that we have to create whose Young's modulus is 3E7 psi and the Poisson's ratio is 0.3. Okay. So the mean diameter that is given is 120, thickness is 1 inch, length of the pressure vessel is 100 inches, pressure which is acting on the inside walls is 500 psi. Okay. Now, because we have to consider that the pressure vessel is closed from both the sides, we are going to apply one axial pressure force which is of 5654866.8 lbf. Okay. Now, why we are considering this? Now, because it is going to be closed from both the sides, okay, we will have to apply a force, okay, and we will calculate this force based on the pressure, okay, and the area of the circle. So this is the formula to calculate this force, which will act actually on the pressure vessel from the top, just to create the closed section condition. Okay. The other boundary conditions acting on the model is that the base of the pressure vessel, we are going to apply one frictionless support over there. Okay. So this is the model that we have to create. Now in the results, they have asked us to calculate the axial stress and the Hooke's stress for the vessel. Okay. Now before we start solving this problem, let us first understand what is Hooke's stress. Okay. Now, whenever we have a thin walled vessel whose wall thickness is not more than 1/10 of its radius, we can calculate the Hooke's stress, and the equation for calculating that Hooke's stress is P dm divided by 2T. P is the pressure acting, dm is the mean diameter, okay, which can also be calculated by outside diameter minus T, and sigma theta is nothing but the Hooke's stress. Okay, now if you look at the diagram, the Hooke's stress generally acts in the radial direction. Now please understand over here, axial stress is the normal stress parallel to the axis of cylindrical symmetry. So if this is your pressure vessel and this is the central axis, the stress which is in the normal direction, okay, will be the axial stress. Okay. Then radial stress is the stress in the directions coplanar with but perpendicular to the symmetry axis. Okay. So now if you consider this is your pressure vessel, if you consider this point, okay, the pressure or the stress which is acting in the radial direction, okay, will be the radial stress, and this stress over here which is acting in the tangential direction, or it is also called as the azimuth direction, will be the Hooke's stress. So if you look at this diagram, you will see sigma A will be the longitudinal stress or the axial stress, sigma R will be the radial stress, and sigma c is the hoops stress. Okay, so we have understood how to calculate, what is the formula for calculating the hoop stress and what is the hoop stress and how does it act. Okay, so now let us go and solve this particular problem. So I'm going to create one static structural system. Now let me call this as Axisymmetric model. Okay, I will have to enter into the engineering data because I need to create a new material. Okay, let us call this as material 1, enter, and then we need to add the material properties. So I need the Young's modulus. So Young's modulus is in PSI. Okay, as per the data, if you see the data over here, it is 7 e raised to 7 psi, and the Poisson's ratio is 0.3. So 3e7 and the Poisson's ratio is 0.3. So depending on that, the other values are getting calculated. Okay, we will return to the project. Now let us create the geometry. So we will double click on the geometry. The unit system that I have to use is inches. So once you enter into the geometry, you will set your unit system. So change the unit system to inches. Okay, and now create the geometry. So we will click over here, enter into the sketching tab. Now I'm going to create one rectangle over here. Okay, and let us give the dimensions. And click on the horizontal dimension. Okay. Fine. Now change the dimensions. So H2 has to be 1 inch, V1 has to be 100, and this has to be 60. So you can see that it is a very thin walled pressure vessel that we have. Okay, right. So the model is ready. Now I am going to create revolved object. Okay, the axis is this. But because it is going to be an axis-symmetric problem, we can only create this cross section. We can only create this cross section and take it into analysis. But for that, you need to be very sure that before starting the analysis, okay, I will add one more. Okay, I'll just repeat the procedure again. While you are entering into the geometry, you need to make sure that you set your units. You need to set your type of analysis as 2D. Please make sure that you make this change if you are going to solve a axisymmetric problem. After that, enter into the geometry and create your model. This is a major change which you need to take care. If you don't do that, you will not be able to solve your problem. So again, we will have to go and create the model again. Dimensions, length, thickness. So this has to be 100, this has to be 1 inch, and this over here has to be 60. So 120 is the mean diameter, so I am taking this to be 60. After that, because we have to solve it as an axisymmetric problem, I'm not going to create the revolved body, but I'll come into concept and I'll say surfaces from sketches and create a surface. Okay. So we are going to use this model for my analysis. Okay. So exit and now enter into the model. After you enter into the model, so you need to click on the geometry, and in the once you click on the geometry, in the details view you will see one option over here, 2D behavior. So as we discussed earlier, we have different types of problem: plane stress, plane strain, and axisymmetric. So change it to axisymmetric problem. Okay, this is the first thing that you will change, after which I need to change my material. So we have created one material mat 1, I will apply that. Then carry on with your general procedure, mesh the model first. So we have used the default mesh settings to create the meshing. If you wish, you can change the settings over here. After that, click on the static structural node and apply the boundary conditions. So according to the problem, I have to apply one frictionless support on the base edge, which has been done, and then I need to apply one force whose value is, you can see over here, this is the value of the force that has to be applied. So it has to be on this edge. Okay, the value is, I need to change my unit system to US customary so that the unit of the force changes to LBF, and it is 5654866.8. Okay, you can see the value. After entering the value, you need to check the direction of the force. So the direction of the force has to be in the upward direction. So I will use this edge over here to give that direction or specify that direction, and we will apply this. Okay. So now the frictionless support is done, force is done, and now I need to give another pressure which will act on the inside of the walls. I'll use this edge and then enter the value. So 500 psi is the value of the pressure. So we have applied the boundary conditions in the form of frictionless support, force, and the pressure. And now we will solve it. Now in the results, we have to calculate the axial stress. Okay. So axial stress, for calculating the axial stress, we will come into stresses, and now we are going to use the normal stress, which will give me stresses in a particular direction. So I'll click on normal stress. The axis I'm going to use is the y-axis for defining the axial stress. Okay, and I'm going to use the z direction for getting the hoop stress. Okay, so from here we have already understood what are the directions and how they act. So if your cross section is over here, this becomes the tangential direction and this is the radial direction. So according to the model that I have created, okay, if you look at it from this side, okay, the z direction becomes the tangential direction. That is why we will select the z direction over here. You can also take the total deformation, and now we will solve. You can wait for the analysis to finish. And now you can check the values. So the axial stress we have got is 15,126 psi, and the hoop stress that we've got is somewhere around 29,750, which is close to 30,000. The total deformation that we've got is 0.054189 inches. Okay, so this is the value that we've got. You can also check the radial stress, which is in the x direction, and we can solve. So with this we will get all the three stresses, that is the axial stress, hoop stress and the radial stress. Okay. Now, because we have created an axisymmetric model, and if you want to see the results for the complete model, we are only considering the cross section, but if I want to view the results in a complete model, we'll have to do a few changes. Come to the project window, go to the tools options. In this, you can click on the appearance option over here, and in appearance, switch on the beta options over here. Once you switch on the beta options, again enter into your model cell. Okay, and then click on the model node over here and click on one symmetry, add one symmetry region. When you click on the symmetry region, the type should be 2D Axisymmetric, and we are going to have 37 elements, where each element will have 10 degrees of rotation. And now once this change has been done, once you click on the normal stress, look at this. So you will get your answers. Can you see this? So we have created one cross section, but the results can be viewed for the complete model. So this is how you will perform an axisymmetric problem in Ansys Workbench.